Recrystallization is a laboratory technique used to purify solid compounds. It is often used after chemical synthesis to remove impurities from crude products. Recrystallization is based on the principle that solid compounds tend to be more soluble in hot liquids than in cold liquids. The first step is finding a suitable solvent in which the sample can be purified. In a good solvent, the sample should be soluble when hot, but the same solvent should not dissolve the sample at room temperature. If a single solvent that works cannot be found, a two-solvent system should be tested. Once a suitable solvent is found, the crude sample can be placed in an Erlenmeyer flask. This type of flask is a better choice than using a beaker, since the conical-shaped sides help to trap solvent vapors. Heat the chosen solvent on a hot plate or in a water bath, but never use flames, as solvents are very flammable. Heat the solvent to its boiling point. Add a small quantity of the hot solvent to the sample in the Erlenmeyer slowly. Keep adding very small amounts of the solvent just until it dissolves all the sample. Once all the sample has dissolved, set it aside and allow it to cool down to room temperature. Once the sample is cold to the touch and some crystals have formed, it can be further cooled in an ice bath to maximize the yield. If crystal formation cannot be observed by this point, a glass rod can be used. Scratching the walls of the flask and stirring the solution with the rod can initiate crystal formation. Alternatively, a seed crystal of the same compound can be added. Finally, the pure crystals need to be separated from the solvent, which contains the impurities. The crystals can be isolated by Bushnell filtration and rinsing with pure, cold solvent to remove the last traces of impurities that might be sticking to the crystals. Once the filtration is complete, allow the crystals to air dry.